Good day, everyone. Welcome once again to my channel. This is Engineer Reagan. Today, please join me as I will try to evaluate and solve this exponential expression. Um, this is a trick question, by the way, but if you want to enhance your problem solving capacity, this is a very good practice for all of you, especially for those people who will be taking the college entrance test for the prestigious universities we have here, like UP, Ateneo, and LaSalle. Or if you are an engineering student and you just recently graduated and you're planning on taking the engineering licensure exam, then this will be a very good practice set as well for you. Okay, um, so let's start. Okay, so we have here a condition. Okay, we have two conditions here. It says there that x plus y is equals to 2y and b squared is equals to ac. Then we are asked to solve for a to the power of y minus z, b to the power of z minus x, and then to the multiplied by c to the power of x minus y. Okay, okay, the first thing I'll do here is I will first use the first equation, okay, and then I'll express x in terms of y and z. That's right. Okay, and then after that, all I need to do now is just substitute, okay, the values. I now have b to the power of z minus, okay, instead of x, now I have already expressed as x, I have already expressed x as 2y minus z. So instead of just writing x, you now have 2y minus z. Okay, and then again multiplied by c to the power of, again, x. You now have x expressed in terms of y and z, so this becomes now 2y minus z minus y. Okay, and then further evaluate. Okay, y a is equals to y minus z, and then b, you have z, distribute the negative sign, minus 2y, this becomes plus z, and then times c, evaluate this one, 2y minus y, you all have y left, y minus z. Okay, it makes sense so far? Good. Okay, now next is further simplify it, y minus z, and then, okay, you have there z plus z, then you will have b to the power of 2z minus 2y, right? And c is equals to y minus z. Okay, so we're getting closer, friends. A to the power of y minus z. B, I'll factor out the 2 since 2 is common. Z minus y, right? Then multiplied by c to the power of y minus z. All right, we're almost there. Okay, now please agree with me if I say that b squared, b to the power of 2 times z minus y is the same as b squared to the power of z minus y, right? Because according to the law of exponents, when you have an exponential expression raised to another exponent, all you have to do with exponents is just multiply it. Okay, so you can do even the vice versa of that process. So basically, these two expressions are the same. Okay, so I will now have c to the power of y minus z here. Okay, and then from there, I will have a to the power of y minus z. B squared, as given in the condition, is equals to ac. So instead of just b squared, I will now have ac all to the power of z minus y. Would you agree? Y minus z. Okay, now, before we get any further, please notice that the exponents of a and c here, this one, this term and this term are both y minus z, while the one at the middle, this one, okay, is z minus y. So meaning it's not in order. So first I will have to conform their exponents so that they will look the same. So this becomes now AC. Would you agree if I'll take out the negative, it would look like y minus z, right? And then c to the power of y minus z. Agree? All right, that's good. Okay. After that, okay, according to the law of exponent as well, if you have a negative exponent, you can transfer that from the numerator to the denominator and vice versa. Okay? Okay, so if you have a negative exponent, so basically, this now becomes a to the power of y minus z times c to the power of y minus z all over ac everything to the power of y minus z. Now, if you've noticed, they all have the same exponents now. So again, by employing the law of exponents, I can just distribute this, right? This exponent to each of the factors below. So it becomes now a to the power of y minus z times c to the power of y minus z. And since it's common, this one, c to the power minus z is the same as the one in the denominator. So I can just cancel them out. The same as this one. So the whole thing is just equals to 1. That's your answer. Okay? So meaning the whole expression, this thing, is just equals to 1. Okay? So once again, it's my privilege to show you another mathematical problem solved. Okay? That's all. Bye.